Hello everyone, I'm Çağatay Kara. Today I have a presentation about material science. I read an article about mechanical effects during auxetic foam fabrication, and I will give some information about auxetic materials. Firstly, I'm starting from basic information. What is that? Position ratio. As you know, position ratio means strain ratio in the force direction and the other direction. For example, if we have a tensile force in a one direction, normally there's a compression, there's a decrease in the cross-sectional area. It means that negative strain in the cross-sectional. The ratio of this strain and the cross-sectional decrease, cross-sectional strain gives us position ratio. Generally, position ratio range from 0 to 0.5. But also there are some materials which has negative position ratio. We're gonna see them next page. In here, for example, you can see that there is a longitudinal strain, longitudinal force, and the positive strain at that direction, also negative strain at the lateral direction. This gives us a positive position ratio, as you can see here. There's also negative position ratio. If there's a tensile force, for example, there's a both in that direction and both the perpendicular direction, there's a positive strain. This gives us a negative position ratio because of the formula, the negative sign in here. At that picture, I'm going to say something about structure. This is a convex structure, you can see, and this is a concave structure. At the structure of the materials, if there is a convex bonding between the molecules or atoms or some subparticles, our materials are more prone to being positive position ratio, I mean conventional materials. If the bonding or interactions between atoms or molecules are concave, this makes our material auxetic. You can see here also. In the nature, we can see negative position ratio, I mean the auxetic materials in our muscles. There is a link between muscles and the bones. This means Achilles tendon. Achilles tendon has a negative position ratio. It's an important point that, for example, if there's a tensile force, our cross-section is increasing, and the stress transfer to bones are decreasing because of the increased cross-section area. In industry, because of the low density and the absorption of energy, we can see the negative position ratio material in the shoes, especially sport shoes. Also, because of the toughness and the fracture toughness, we can see in the military vehicle. Also, body armor. They are preferred in that kind of materials. Auxetic materials are preferred. In my article, I read how can an auxetic material can be produced. This is a production method. This is a foam, and we are putting this foam in a compression mold. And also we are putting two aluminum block and we are compressing it. What is the important point in this manufacturing point? There are three important parameters actually. VCR, this is the most important one, volume compression ratio. You can see that these are material, then it becomes like that. The compression rate from the all of the sizes gives us VCR. Porosity means number of porosity in a unit square area. It means our materials are consist of porous or lattices. Number of porous increase means more negative ratio. Heating time at the TG means TG is a glass temperature. At the end of this process, we are heating our system at the TG glass temperature. The interval of that time makes our material more negative position ratio. I mean, it's a little bit complicated. I'm sorry for that. These three parameters are have a parallel relationship between negative position ratio. Yeah, that's all. Thank you for listening.